Few people are aware of the strange origin of some of our most widely used pharmaceuticals and medicines. When you buy a bottle of pills or receive a shot, you generally do not think about where it came from. Many individuals generally expect that medicine or surgery will help them without any potential harm. And if you've ever been one of these people, feeling safe because of the medicines or surgeries that you've needed and have helped you, you should be aware that a horseshoe crab saved your life. The horseshoe crab is a fairly primitive arachnid that scavenges at the bottom of the ocean. They are found most commonly in the Atlantic and around Asia. There are only 4 known species as of present day. Horseshoe crabs live for about 12 years and have no known predators. Their thick shell acts as armor against predation. The earliest fossil has been dated to be roughly 450 million years old, when marine life dominated the Earth's surface. They maintain a simple physiology and the most basic yet effective immune system known to man. Although at first sight this creature's strange shape and many legs may be considered unattractive, it possesses medical gold in its blood. It has qualities to protect against disease and infection that are much more effective than that of other animals. These qualities act to create a barrier whenever a pathogen enters the horseshoe crab's body to prevent the spread of anything foreign. In 1885, W.H. Howe first documented the clotting properties of this blood. It wasn't until 1950, though, that Dr. Frederick Bang recognized the distinct correlation between bacterial endotoxin and limolus blood coagulation. Through his work at the Marine Biological Laboratory at Woods Hole, Massachusetts, he was able to provide enough research and documentation to allow a derivative of this blood to be created for the purpose of testing for sterility in medicines and medicinal devices. The blue blood of the horseshoe crab, colored for its content of copper, is filled with amoebocytes. Similar to the white blood cells of mammals, amoebocytes act to prevent spread of disease whenever bacteria or pathogens attempt to enter the horseshoe crab's body. If a horseshoe crab sustains an injury, amoebocytes crowd around the area and coagulate to create a barrier. Unlike the white blood cells, though, amoebocytes do not target specific markers. They respond to all foreign cells. Considering the large variety of bacteria in the ocean, their nonspecific immune system is much better adapted for that environment. Scientists have been able to extract amoebocytes from this blood to aid in testing the purity of vaccines and medicines. If curious about the sterility of a substance, scientists place the horseshoe crab blood derivative, LAL, into a sample. If the sample is contaminated with gram-negative bacteria, then it will thicken. Biomedical companies are able to extract the blood of horseshoe crabs without harming them. They remove about 1/3 of the crab's blood, which takes roughly 30 days to replenish. The mortality rate for this process is less than 10%. Some controversy has risen between fishermen and the medical industry about the dwindling numbers of these creatures. Originally, both parties had no restrictions and horseshoe crabs were over-harvested in Asia and the east coast of the U.S. Luckily, though, there are now regulations put in place regarding the number of horseshoe crabs that can be used in order to avoid negatively affecting their population. The FDA now requires LAL tests for intravenous medicines and any injectable medicines. It is also used for prosthetics and to test for spinal meningitis and certain other diseases. This derivative determines whether something is safe to put in or on the body, or if it could be harmful to a patient. So the next time that you receive a flu shot, a vaccine, antibiotics, or receive surgery, consider how the horseshoe crab's blood may have aided in saving your life.